Bienvenidos, Ushamdeen, and welcome Anne Arundel Community College learners for the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and in this tutorial video we're going to be focusing in again on Lab 1.3.3 Python Programming Review. In this video, you're going to learn how to use the if-else statement. You're going to see many examples of if-else. We're going to take a look at for loops, and we're also going to take a look at while loops. So let's go ahead and dive in. Now, as I've previously stated, you do not need the DEVASC virtual machine in order to complete this work. And in fact, in this video, I'm going to be using my native Mac OS operating system here. And we're going to do everything that we need to do because I've already downloaded from python.org and installed Python 3.11. So the first thing that we want to take a look at is the if vlan.py script that they ask you to create. Now, if you were to type this in exactly as you see it here, and place it into VS Code and then go ahead and run it, it's going to do exactly what you need it to do. Again, I'm using the Vim or VI improved editor, which is a little bit more difficult. However, it's going to allow me to quickly make some changes here that are going to need to be made throughout this activity. So what do we have? Well, on the very first line where we have some Python code, we have a variable, native VLAN, and we set the value of that or assign the value of that as 1, because the native VLAN is 1. And then we put a data VLAN value in here as 100. Now remember, lines that begin with the pound sign, these are comments. And so this code right here for now is going to be ignored. But now we go into our if statement. And so we're checking to see if the native VLAN is equal to or the same thing as the data VLAN, then we're going to print out that the native and data VLANs are the same. Otherwise, we're going to print that they are not the same. So let's go ahead and run this program before we edit it to see what it's going to do. So from the command line, I would simply type Python 3 if-vlan.py. And the native VLAN and the data VLAN are different. Okay, well, we can clearly see that 1 is different than 100, but how can we spice this up a little bit? Well, let's do this. Let's go ahead and comment out the fact or comment out the statement that is assigning the value of 100 to the data VLAN, and let's prompt the user to enter that value. Now, I'm going to leave it just like this, and what do you think is going to happen? Well, let's find out. Let's go ahead and rerun the program, and I'm going to enter the data VLAN number as 99. Now it comes up and it says the native VLAN and the data VLAN are different, which they are. If I was to rerun it and say 1, please enter the data VLAN number, it's going to come up and say the native VLAN and the data VLAN are different. And I'm doing this intentionally. Now, why do you think when I enter in 1, which is clearly the same value as the native VLAN, that we receive an error? Well, if you're taking a look at this, you probably noticed that the native VLAN statement, the declaration or assignment statement here, sets the native VLAN to the value of 1 that is an integer. However, the input function we know returns by default a string. And so how can we check that? Well, let's come down here and let's drop in two more print. We'll drop in two more print statements. And I'm going to say native VLAN. We're going to print the type of the native VLAN down here at the bottom. And then I'm going to go ahead and copy that statement and just change the word here. And we're going to do data VLAN. So we're going to print out the data type for the native VLAN and the data VLAN to see why it might be that Python says that 1 is not equal to 1. And that is why, because we are comparing an integer value to a string value. Now, there's a couple of ways that we can address this. Let's go ahead and approach it with the typecasting approach that we had used earlier, and we can do this right here, where we take as an argument to the integer function what the input function is going to return. In other words, what the user enters in, and we're going to typecast that to an integer. And so let's go ahead and rerun the program with the typecasting in place, and I'll say 1. And now the native VLAN and the data VLAN are the same. And so this is probably the way to approach it, because we're anticipating that you're going to be entering in a whole number, an integer, and so we would want to treat it as an integer. Can you think of another way we might want to approach this? Well, what I could do is I could have left the typecasting out, and we'll go down here to the end of the line and get rid of that one, and I could have come up here and done the following. Whoops, and we'll make this a string. So if I make the native VLAN value a string and we rerun the program and I say 1, they're both strings, and so the native VLAN and the data VLAN are the same. So again, many ways we can approach this. I prefer the typecasting approach. However, I want to make sure that you see that there are multiple ways to solve this problem. Let's take one last look at the if-VLAN program, and there it is as it stands right now. Again, without the typecasting, we set the native VLAN to a string value. So definitely be on the lookout for small little tricks like that. Okay, so that takes care of our if-else. Now we're going to create an if-elif-else statement. In other words, we're going to be checking for a couple of things, and if those things aren't true, then we're going to go ahead and print out sort of our catch-all at the end. And we're going to do that by using our if-acl.py script. So what are we doing here? Well, here we're creating a variable called ACL number, and you can see I'm already doing the typecasting so that we get an integer back from that user input. So what is the IPv4 ACL number? We're going to type that in, and then we're going to go ahead and we're going to walk through and we're going to check to see, first, is the ACL number greater than or equal to 1 and less than or equal to 99? Now, if that's the case, we're going to print. So in other words, if that's true, if both of those things are true, if the ACL number is greater than or equal to 1 and less than or equal to 99. In other words, it can't be 100, because then this would be false, because both of these statements need to be true in order for the entire if statement to be true and result in the printing of that print statement, that this is a standard IPv4 ACL. And then we have elif. In other words, if this is not true, in other words, maybe they enter in 110. Well, then this would be false, and we would come down to the next line to evaluate. Now, something that you're seeing in here, which is important, is the indentation. So you'll notice the if statement is terminated with a colon, and then the next line is indented 4 spaces. And you probably saw this or thought it might be odd in the previous example. Why are we indenting here? Well, it just so happens that Python doesn't use the curly braces in order to maintain blocks of code together. It uses indentation. Now, you can use 2 spaces, you could use 3 spaces, you could use 5 spaces. However, I'm going to introduce you to something called the Python Enhancement Proposals, or the PEPs, as they're typically referred to. And specifically PEP number 8, which is the style guide for Python code. Now, this guide, and the lab tells you the same thing, is going to encourage you, when you're using indentation, to use 4 spaces per indentation level. And you can see they've got some examples here of what that might look like. So all of the examples that I create, and this is what I do when I'm writing my Python code, is I use 4 spaces for my indentation, meaning that this print statement right here goes with the if statement that is directly above it. If I wanted to have another print statement here that if the if statement above is true, we're going to print out, we could print a second line out. I'll just put thanks, right? So both of those lines are going to print if and only if this is a true statement. And again, for this to be true, both of these conditions need to be true. And so think of it as like a Boolean. We're going to get back, it's either true or false. It's one of two things. That's it. So now we come down to the next line where if these are both not true, then that's false. So if it's false, we would come down and take a look at the elif. Well, this is just basically saying, you can think of it as an English translation like, well, okay, it wasn't true above. Well, maybe this is true. So now I'm going to check to see, well, is the ACL number greater than or equal to 100? And is the ACL number less than or equal to 199? Because that's the range for the extended IPv4 ACLs. Now, if both of those statements right there are true, then this elif statement is true. Therefore, since that is indented underneath the elif, it's going to print this is an extended IPv4 ACL. Now, if that is not true, if the if statement is not true, and that is not true, in other words, maybe the user entered in 500, we have a catch-all down here, this else statement. And again, we've got 4 spaces, 2, 3, 4, indenting here underneath the else statement, and that is what would print up. This is not a standard or extended IPv4 ACL. Now you might be looking at that and saying, well, wait a second. There are other ranges, and I'm on a Cisco 2811 router here, and you're absolutely right. However, for the purposes, let's get in config T here real quick. There we go. For the purposes of our lab, we're not going to be taking into account the expanded ranges, right? Now, maybe you can edit this program to account for the expanded ranges. So for standard ACLs, it's 1,300 to 1999. For extended ACLs, the expanded range is 2,000 to 2699. Excuse me. How might you work that in here maybe, right? Maybe you extend out the elif statement, or maybe you add in additional elif statements, right? How would you approach that? So maybe you drop your code down below in the comments section so I can see how you might approach that. And again, I'm going to put a space here. I'm not a fan of having things run right up against it. All right, so let's run this program and let's see what happens. So I'm going to say Python 3 if-acl.py, and let's hit enter. So I'm going to say first it's 22, and we know that that is a standard ACL. And there we go. And both print statements come up. And that is it. As soon as one of those statements is true, the program is done running, because we don't need to evaluate the elif because it's 22. So it matched the if statement. That if statement was true. So then that is it. And then you've got the second line thanks that we wanted to print. Let's rerun this. Now, what if I was to put 100? Now, that's an extended IPv4 ACL. What about 101? Yeah, let's check 199. And again, oops, sorry, I'm just checking to see, okay, is it going to get that greater than or less than or equal to? And it's working beautifully. Finally, let's check 500. And what we should see here is that this is not going to match the if. It is not going to match that elif. It's going to fall all the way down to the else statement. And it's going to print, this is not a standard or extended IPv4 ACL. And my point with showing you on the router was that, well, what if I enter in 1,300? Well, that is an expanded range number for a standard ACL. So maybe we want to take a look at the program a little bit more closely to see, hey, is that going to work, right? Is that going to do what we need it to do? So one more time, let's take a look at the if-acl, and you can, again, simply retype this code into VS Code and execute it. All right, so there's our script for that. Now, we're going to take a look at the for loop. And so to do this, I'm going to pop over here. We're at the Python Interactive Interpreter. In fact, to exit out, I can do Control-D. And then you can see here, I'm running the latest and greatest, 3.11.2. And we're going to work with the for loop. Now, the for loop is used to iterate through things that are iterable, right? That you can iterate over. Now, a list is a great example of something that you can iterate over. So if I was to say devices, and we're going to assign a list here of R1, R1, we're going to do R2, we're going to do R3, and then we're going to have some switches in here. We're going to have switch 1, and, and we're going to have switch 2. So we've got multiple devices here in our list. Again, to check that, I can simply say type devices, and it's going to tell me that it's a list. Now, quickly before we get into the rest of the code, if I wanted to see the last item in this list, -1, right? We would index into that list using -1, and that's always going to give me the last element of the list. The first element is always going to be at index position 0. Remember, Python is a zero-based counting language, so when we're in lists, and specifically this list, that's 0 from an index position, that's 1, that's 2, that's 3, and this would be 4. Now remember, -1, -2 if you're using negative numbers, -3, -4, and then -5. And so let's check that out. Is -5 actually going to give me the same result as 0? So we'll clear the screen here, and let's say devices -5. And there we go. That is the first element at index position 0, but using the negative numbers, it would be -5. Again, now that would change if we either grow or shrink the number of elements in the list. So you got to be careful there. If it's like, what's the first element in the list? Then you're going to use 0. What's the last element in the list? We're going to use -1. All right. So we have this list right here, devices, and so now we're going to run a for loop. So I'm not going to do any spaces here, and let's see what happens if I just simply type in for item. Now, item is simply a placeholder. It's a variable name of sorts, and here's how that's going to work. So I'm saying for item in devices, and again, you can see we get the little 3 dots right here. So item is what I'm going to refer to later. And what item really relates to here, or what we're referring to, is that item in the list, this item in the list. As we iterate through the list one item at a time, that item in the list, this item in the list. And so it's basically saying for, and you can maybe insert in English here the word each. So for each item in the list, devices is really what this is saying in English. So for every item that's in the list devices, I'm going to start at the beginning from index position 0, and I'm just going to go through the list, and I'm going to let the program print out each item that's in that list. Now, remember, I said I'm on my Mac here, and you'll notice I haven't been typing any spaces. So let's see what happens when I say print item. And again, for every item in the list devices, just print it. Well, let's see what this does right here. And we're going to end up with an error. And you'll notice we end up with an error. It's an indentation error. Expected an indented block after the for statement on line 1. And you can clearly see here that it's telling me, hey, the print statement, you needed to indent that, right? So the declaration of the list, that is its own little block of code. So there's my list. Now let's go back to the for item, and we get those 3 little dots. Now remember, those 3 little dots are going to be your reminder to indent 1, 2, 3, 4 spaces, and then say, what am I going to print? Well, I'm going to sit there and I'm going to iterate over that list of devices, and I'm going to print each one out to the screen. Now you'll notice I hit enter and it doesn't do anything. We're going to hit enter one more time because, again, it's assuming, well, maybe I want to do another print statement here, or maybe another piece of code. However, we're done, so I'm going to hit enter, and there you go. So for each item in that list, I simply printed each item. That's it, right? And that's how you can kind of think of for loops, is they're going to allow you to iterate over things. Now, they show you an example here of, well, what if I only want to print the routers? And this is where we're going to look at the Python keyword in, which is just IN. So let's go ahead and do a Control L here. So there's my list of devices, right? There's my array with my list of devices. And let's go ahead and say for item in devices. And again, this is I'm saying for each item that is in that list with the name devices, here's what we're going to do. There's my 3 dots, and that's my reminder. Hey, let's indent here. So I'm going to check each of those items, right? So if there's a capital R in the item name is what we're looking for there. And that's how you say that. So if R is in the item name, then what are we going to do? Well, 1, 2, 3, 4, and we know that we need to indent again here, 1, 2, 3, 4, because indentation is what groups together the blocks of code that you want to function together. So if and only if the item has a capital R in the name, are we going to print that item? And there we go. So for R1, R2, and R3, that if statement is true. Therefore, it prints the item, right? In other words, it prints that element of the list. But when it got to switch 1 and switch 2, there is no R in those names. So what is it going to do? It's just simply not going to print them. It just simply skips over them. And so that's an approach that you can take there. Now, what about the switches? So here's what I could say. I could say switches, and I'm just going to create an empty list. If I was to say type switches, you'll see that it's a list. It just doesn't have any elements in the list. So devices still exists, right? So if I was to type out devices, we still have that list, right? Because we're not changing the list with what we're doing with the for loop. We're just iterating through the existing list. We're not actually changing anything. So what could I do here if I wanted to gather up all of the switches? Well, all 2 of the switches anyway. So what I could say is for item in devices, hit enter. There's my reminder. 1, 2, 3, 4. What am I checking for now? Well, I don't want to check for the R, but I could say if there's a capital S in the item name, then 1, 2, 3, 4, 1, 2, 3, 4. If that is true, then to the empty array that the empty list that we created right there, what are we going to do? Well, we're going to append every item in that list that has a capital S in the name. Hit enter and hit enter again. Now, we don't see anything because remember, we didn't tell it to print anything. We simply said, if there's a capital S in that name, then append that switch, or that, I should say, that element that has the capital S in the name to the list switches. How can we see what's in there? I can simply type in the name switches, and that's it. Now, that's a great approach, and it's something very, very simple to understand. If I was to come over here, I actually created the script called the for loop inside of a script. So let's take a look at cat for routers and see what we've got here. And that's what it would look like inside of a file. Again, the code is very similar, and I'm actually combining things there. I've got some additional code in there that I was going to walk through, but we can just do it from the interactive interpreter. And then let's take a look at the for switches code and see what that looks like. And there you go. And this is an instance of where I have previously commented that you would initially at the top of your file or somewhere near the beginning of your file, your Python script, you would actually create the empty array because if this, I'm sorry, I keep saying array, list. So you would create this empty list because if you're going to append something to a list, the list needs to exist. So let's take a look at what happens if that list doesn't exist. So I'm going to go ahead and say for switches, and let's comment out the creation of the list. And here's what's going to happen. We'll clear our screen, and then we'll say Python 3, and we'll say for switches. And you can see what happens here. It says name error, switches not defined. In other words, I can't append to something that doesn't already exist. So this is not going to create the list for you if it doesn't exist. Now, if the list does exist, then it should do exactly what we think it's going to do. And you can see I print out that list down below, and there we go. So that's how you could append things to a list. Now, the last thing that we're going to take a look at is the while loop. And it wants us to open up a blank script and save it as whileloop.py. Well, you'll notice that we have whileloop.py right here. Now, at the very beginning of the program, it says, prompt the user for some input here to enter a number to count up to, and then this is another sort of less Pythonic way to convert X, which would be a string, because that's what the input function is going to return to us by default. And then this is just this extra line of code that says, okay, now make X an integer, right? We're going to typecast X to become an integer. Well, we already know that there's a much easier way to do this, and so let's do that. There is a better way to do this. So I could say int, and we're going to typecast it all in one line because it saves us from having this extra line of code there. Then we're going to set y equal to the integer value 1, and then we're going to check something here. And again, this is a Boolean expression. There's our Boolean operator right here, less than or equal to. So while y is less than or equal to x, so while that statement is true, we're going to print the value for y. And again, y starts at 1. So then we're going to print 1, 2, 3, 4, and we're just going to go through and continue to print all the way up until y is no longer less than or equal to x. Now, remember, the user's entering the value that we're going to be using for x. Y starts at 1, and then it just increments inside of this while loop. So each time the loop runs, while is being incremented by 1. So sooner or later, you're going to get up to whatever the value is you entered for x. Now, there's also a better way to do this right here, and let's go ahead and do that right now. So I'm going to comment this out. Whoops. I'm going to comment that out. And let's get up on the right line. Whoops. And here's what we're going to say. So you can say y gets the value of y plus 1. That's going to increment y. But we can also say y plus equal 1. That does the exact same thing, or it gives us the exact same result as the line below it. It's just sort of the shorthand approach to saying y gets the value of y plus 1. You say y plus equal 1. So there is a fancier way, a more Pythonic way to do that. And so let's go with that. Let's run the program here. Let's say Python 3, whileloop.py. I'm going to count up to 6. And you can see the first time that it runs, the value of y is 1, and that's what it prints. And then it increments y to 2. And it's going to check. Every time it's checking, is y less than or equal to x? Now remember, I entered in 6, and that was the value for x. So when we get here, it prints 6, right? And then it checks, is y less than or equal to 6? And yes, 6 is less than or equal to 6. But after it prints 6, it increments y by 1 to 7. And then the while loop, that Boolean condition, fails. And that's it. Once it fails, the loop is done. Now, that was a very easy way to do that. Now they're asking us to check something else. It says they want us to modify the while loop, and instead of using y less than or equal to x, can we modify it to check and then break to stop the loop when the check evaluates the false? So how would we do that? Well, let's go back into whileloop.py. And here's what we can do. I'm going to go ahead and we're going to leave that line of code right there because we still need to prompt the user. We're still going to set y to 1, but here's what's going to change. I'm going to comment out these lines of code here. Remember, oops, and those were kind of already commented out. Now they're double commented out. And we're interested in these 4 lines of code here. I kind of staged it so I wouldn't have to type it all out. So now we're checking to see while true, right? So instead of saying while y is less than or equal to x, I'm saying while true, meaning this is true forever unless I either set it to false or we break out of the loop. So here's where I'm simply going to print y. Remember, y starts with a value of 1. And then I'm going to increment y by 1. And how could we do this a little bit more elegantly? Well, let's go ahead and fix this. Y gets the value. Whoops, I'll pull all that out of there. So y gets the value of plus equal 1. And that's how we want to say that, right? That's a little more Pythonic. And now we're going to have a check down here. And again, this is just another way to approach it. So if y is greater than x, meaning up until the point where y is equal to x, I'm going to print the value of y. So it's doing the same thing. But as soon as y is greater than x, we break out of the loop. That's it. The while loop is done. And we continue on. If there were other lines of code, and let me put one down here. Right? This is outside. It's not indented underneath that while loop, so it's not part of the code that's going to execute as part of the while loop. So let's go ahead and say, you did it. Something simple, something stupid. But you'll notice that that is only going to print after the while loop is done. So let's run this and see what happens. We'll clear the screen. We'll say Python 3 while loop. We'll count up to 6. And there you go. And you'll notice when it says you did it, it only says that one time because I didn't indent it under the while loop block of code. Indentation in Python is the key, right? So remember that. All right, so that did exactly what we wanted it to do. Now what we're going to do is we're going to give the user an option, or we're actually going to check to see if the user enters something else and maybe they want to quit the program, right? Because with the while loop, one of the problems might be that it never ends, right? While true is going to just run and run and run and run until something else is false. All right, so there we go. And let's go do this. Until this while statement is false or we break out of the loop, that loop is going to run forever. And so here's a way where we have two while loops that are in play. And actually, I'm looking at this and my indentation, I believe, is kind of off here. So we want to get 2, 3, 4, and let's put this here. Oops. There we go. And I should be able to do the following dot, dot, dot. Oops, sorry. All right, and then we want to get 1, 2, 3, 4. There we go. All right, so this should work, and typically I put, and this is why I put this down here, into file, so there's a comment that I know that that's the end of my file. So all of this code, and this is what we would say is a nested while loop, right? So it's nested underneath the main while loop right here. So while true, I'm going to just continually ask the user for a number to count up to. Now, I'm only breaking out of the main while loop if the user enters in queue or quit. And if not, we're going to, and what do we do here? Oh yeah, so this is an instance where we would not want to do the typecasting right away. And why not? We want input to return a string. We don't want to typecast a lowercase q to an integer because that's not going to work. So when you're checking to see, hey, if x is equal to q, so if x is a lowercase q or x is the word quit, then I'm breaking out. That's it. The whole program is over. We never get down to this code down here. But if it's not, that means, hey, the user entered a number in, and presumably, I mean, they could enter in, quit with the capital Q in all caps, and that would be a disaster. But for this, what we're going to do is we're going to check to see if they enter a lowercase q or the word quit. And if they do, we're going to break out. That's it. The while loop and the program is over. If they don't, we assume it's an integer that they entered in. It's a number they want to count up to. So now we do our typecasting here, right? We convert that string that the input function gave us to an integer. And then we set y to 1, and off we go into this while loop, which the code should look very similar to the code above, with the exception that we're going to do this here. Right, because that's the way we would want it to look, right? A little bit more Pythonic to do our incrementation. And let's go ahead and run this and see what's going to happen here. And hopefully I didn't mess up any of the indentation. So let's count up to 8 this time. So what's the problem here? So I said 8, but it didn't actually count up to 8. So what's happening? It didn't do it the first time, but it did it the second time. Now you'll notice we're still in that while loop. So anything I'm telling it to type up to, but now I decide, you know what, this is boring. I'm going to quit. So I type in Q and we're done. But let's go back into the program here and let's see. It was right there. So at the very top, I forgot to comment out that line, y equal to 1. We could probably comment that out. Because again, we're just running this block of code that's right down here at the bottom, starting at this while loop. Now again, when everything breaks out, I could go ahead and put in here a print statement saying, great job. Now that's only going to run after the while loop. The main while loop is done running. So let's clear the screen. Let's rerun it. Make sure we cleaned up our stray information. And we did. 5, 4, 3, 2, 1. I'm going to type in Q and now it's going to quit. But we should also see great job. All right, well, that is going to do it. And we only have one more part left in Lab 133, which is going to be reviewing methods for file access. And I'm going to be showing you, they show you the old school way to do it. I'm going to show you how to do it both ways with the open and close that they show, but also I'm going to show you how to do it with open, which saves you from having to remember to close the file. All right, well, as always, I hope you're enjoying the course. Thank you so much for watching. And as always, I hope to see you in the next video.